Number 9, Mr. Murphy has 2 yoga exercise balls. Who has a yoga exercise ball at home? Anybody? Yeah, there you go. See? Mr. Murphy does. Okay. One has a diameter of 20. The other has a diameter of 30. How many times greater is the volume of the larger ball? So, what I taught you guys to do is underline and circle keywords. Now I'm going to wait for my computer to catch up. There we go. All right, so circling and underlining the words that are important to me. What is not important to me is that this is a sphere. Believe it or not, you are not using your formula chart here. You don't need to know how to find the volume of a sphere, but you do need to know what dimension you're in and what dimension you want to be in. So, right now, let's see how many times greater the diameters are. So the diameters are in a ratio of 30 to 20. That reduces to 3 to 2. So the diameter of the bigger one is 3/2, 1.5, times greater than the small one. That's the ratio of their diameters. A diameter is a segment. A diameter is one-dimensional. We want to know how many times greater the volume is, and the volume is two-dimensional. So all we do is take our 1D scale factor, one-dimensional scale factor, and we make it 3D. The way you make something 3D is you cube it. You raise it to the third power. So 3 cubed is 27, and 2 cubed is 9. So it's 27/9 times bigger the volume is. If you wanted to do real world answer, it's 8. Sorry, it's 8. I knew it didn't divide out. 27/8 times bigger, which is about 3.3 times bigger. If you wanted like, what does that mean? How much bigger is it really? So the diameter is 1.5 times bigger. No, you didn't need to use radius at all. Because what's cool is that a radius is 1D and diameter is 1D. So you can use them interchangeably. Number 10. Miss Raines has several spherical pin cushions. I guess she's a big sewer. A yellow one has a radius of 2.5. The blue one has a radius that is half the yellow. So let's go ahead and just write down what the radius of the blue one is. Good. And a red one has a radius that is 3, they forgot the S, 3 times the yellow. So that would be, thank you, you're on it. So I've got yellow, blue, and red, and I have their radii listed. Radii. So all of those are 1D. How does the amount of material, stop right there, amount of material needed. Oh, goodness. Yep. Is that 1D, 2D, or 3D? Good. It's surface area, so it's 2D, two-dimensional. What do you think of when you hear this word compare? I wasn't thinking difference. I was thinking, how many times bigger? Or when I hear compare, I think ratio right away. A ratio is a comparison of two numbers, which honestly it's division. That's what it comes down to. So if I wanted to compare the red to the blue, this would be the comparison of their radii. That's the comparison of the radii. Let's go ahead and reduce that. Let's just reduce it for fun. We don't have to do this step, but sometimes it helps us see what's going on. Obviously, that's a 6-to-1 ratio. That's the ratio of their radii. We want to know the ratio of their surface area. We want to make it two-dimensional. So the way to make something two-dimensional is to square it. So, how's the amount of material needed compare? You need 36 times the amount of material. 36 times. Okay.